Okay, well, it looks like we've gotten quite a few people joining, so I think I will go ahead and kick this off so we can try to stay on schedule. So welcome to this virtual interim for the Routing Area Working Group, focusing on PA multi-homing. I'm showing the note well statement. Just be aware that when you're participating in the IETF, there are implications with respect to IPR. And this is a rather long-winded version of saying that. In this note well, there's another one being worked on, but apparently it hasn't been finalized. So Jeff and I were going to start off with an overview of this virtual interim and sort of the logic behind choice of presentations and so on, as well as some guidance or requests in terms of what we're looking for in the future as well. Because I think we'll continue some of this format in Berlin as well. We already have a couple of speakers lined up who couldn't make this virtual interim, but are willing to talk in Berlin as well. So we'll try to kind of keep the pace of this rather high, but continue to focus on this. So as you can see, we have the agenda posted up here. Hopefully you've had a chance to take a look at the agenda. We have tried to focus on pulling in other participants. There are several speakers from service providers and or enterprises to try to give some perspective on the problem of PA multi-homing or multi-homing with provider-assigned addressing. So we wanted to make sure we pull in input from those who are going to be deploying this or using it. We also have a presentation, so that would be Eric Osborne, Jen Linkova, and John Brashowski's presentations. We also have a presentation from Shu Yang, who is going to be talking about sort of another application of desk source routing. So it's not really related to PA multi-homing, but it's using desk source routing, which is a potential solution for PA multi-homing, the PA multi-homing problem. It's a different application, which is service provider network traffic engineering. And then the last two presentations we have are about implementation experience with desk source routing. One in the vector packet processor, VPP project, and another one in Linux. And note the one in Linux isn't really focused on Linux as a host, but Linux as a router per se. But Matthew can correct me on that, but that's the focus of that. So I assume you all can see the slides changing as well, so jump in if you have any questions. Also, I guess we need to develop a bit of a protocol for how to jump in and ask questions and interrupt. So I would say just unmute yourself and jump in and be kind of aggressive about interrupting so that either me or whatever speaker is speaking doesn't just block you out. So feel free to jump in. So I did want to provide some perspective on overall problem and potential solutions, and kind of look at how we are, what our current focus is, and what it would be good to get sort of more general coverage of the whole solution space, we may end up narrowing down ultimately on one particular solution, but it would be good to get some perspective here. So the basic problem that we're looking at is that a network can't connect to multiple service providers using provider-assigned addressing, but not using that where the service providers do BCP38 ingress filtering. So I've provided some little comments on the slide there. In today's presentations, we're getting perspectives from operators and enterprises on the problem and also to some extent on the potential solutions. Now, so I listed several of the potential solutions here. Jeff Houston, back in Buenos Aires, pointed out that there has in fact been a working group, the SHIM6 working group, which tried to solve this problem, and it worked for 5 to 6 years on this, came up with some protocol solutions. It's generally agreed that SHIM6 was not successful, and I guess the fact that we're here still working on the problem means that it wasn't successful. So we're not covering that today, but Jeff has agreed to give a presentation in Berlin on sort of a lessons learned from SHIM6 so that we don't repeat the same mistakes. So I put that here as not really a potential solution, but something that we should hope to learn from. Some of the other solutions that could be address this problem are relaxing BCP38 in a controlled manner. That is, since BCP38 is the source of the problem, we should potentially be able to modify it in a controlled manner to allow multi-homing. There's some discussion from the service provider enterprise presentations about this topic, but it would be good to get more discussion on that particular topic as well. Another potential solution is tunneling, basically tunneling the wrong packets to the right place. There are variants of that where you go from the CE to the CE or the PE to the PE. Again, this is mentioned a little bit in the presentations, but it would be good to get more discussion on those in either on the list or in future meetings. So the final solution that we have listed here is destination source routing, where the customer network includes the source address and the route lookup to get packets to the correct provider. So we're covering some aspects of this in quite a lot of depth today, but I just wanted to sort of lay out that we should spread our focus a bit initially in looking at different potential solutions before jumping to the destination source routing solution, I would say.
We've tried to also invite silicon vendors such as Mellanox, Broadcom, some others. None were available for the interim. Hopefully, next IETF we could have more significant discussion what it actually takes to look up source and destination within single run.
Thank you. Thank you. And so just one final overview slide before we kind of jump into the presentations is a sort of Venn diagram looking at of the destination solution. At this point, I don't think we've very clearly defined the problem that we're trying to solve exactly, and so that'll come about organically, I suppose. But we do need to spend some effort on this because sometimes I think we're talking past each other. So I've kind of simplified this and said, okay, there's simple PA multi-homing in HomeNet, and then there's complex PA multi-homing in HomeNet. And we had a discussion on the mailing list a couple of months back regarding exactly the problem we're trying to solve. there are some sort of simplifications that one can imagine that would reduce the requirements, and I've just made these, simplified these as simple versus complex. There's a lot of detail in there in terms of, you know, the extent to which we are worrying about the interaction with the host. So far, we've focused mainly on the interaction, you know, once a packet gets to a router, what do we do? But there's a lot of complexity also in terms of actually getting a host to choose a source address properly in the first place so that it can get routed properly in this distance routing. And again, we originally started out working on source test routing for HomeNet. It's gotten expanded into, you know, multi-homing for enterprises, and it's not clear that the requirements are identical. And in fact, it's fairly clear that they're not identical, that they don't completely coincide. And in particular, there's the use case of destination source routing for service provider traffic engineering, which I would say has the least overlap of all of these. It's not addressing the PA multi-homing use case, but it's a potential application of this technology. And so we have Shuyang talking about work on that aspect of source test routing today. So anyways, I just wanted to start out providing some perspective here. And then I think we'll jump into, well, first I'll open the floor up to any questions, kind of ask for any input. And I see that, and if there aren't any questions, I will ask Eric to go into his presentation. So are there any questions? Okay. So the way we agreed to do this was, instead of spending time, you know, giving control of the screen to people, I would just run the presentation off of my laptop, or Jeff if something goes wrong with my laptop. So hopefully we will have, that'll work okay. We'll have the presenter, you know, ask me to advance the slides, and that can also let people who are just flipping through slides at home advance on their own. So I'll turn it over to you, Eric. I can see that you're on, but I can't hear you at this point. Okay. Raised his hand. And in the chat window. So I can't hear Eric. Can anyone hear Eric? Oh, okay. So how about we jump ahead to Jen, because we know that Jen's audio works. And in the meantime, we'll work on Eric, getting Eric's audio working. So can we jump ahead to you, Jen?
Yeah, absolutely.
Okay, thanks. Hold on one second. Let me pull up your presentation.
Okay, I think you can go to the next slide straight away.
Okay.
So yeah, I'm going to talk about like some my experience for the last years in getting some corporate/enterprises network multi-homes in V6. And
Before
what I
you do that, can somebody hear me now?
Yes.
Okay, good. I will shut up and wait for the next presentation. I just wanted to make sure it worked before we got to my slide. Thank you. Sorry, go ahead.
So basically, I used to work for service providers, and when I started looking into enterprise networks, I found that they're completely different, right? They're more conservative in network designs. It means it's really hard to convince them to do something different unless you provide very good reasons to it. They have a lot of legacy equipment, hosts which have limited support, and we can't expect them to be updated. And every time I talk to enterprise people, they most likely are not going to be the last people to deploy V6 in general, right? Because they have not so many reasons to do that as service providers, for example. And on top of this, what they quite often try to do in corporate networks is completely opposite to what end users might want. I mean, we have developed all these privacy extensions for V6, but enterprise network administrators want to know which host was connected to the network and so on, right? So they try to enforce network policies. And the first time I tried to make sure that all solutions, all network designs I'm working with have V6 deployed from day one, I found that, oops, we actually cannot do multi-homing for V6 properly. And if I have some network design which is multi-homed for V4, I could not just copy what we've been doing for V4 and do the same for V6 because it's slightly different. And it actually looks like a real showstopper for enterprise people. So to be honest, I expect that we need some quite simple solution, right? Because if we're trying to offer something which is adding complexity to the network design, they would rather not deploy V6 than deploy something very complex. So, and indeed, with quite often you cannot expect the same level of technical knowledge, I would say, from some enterprises, especially small corporate networks. Like you couldn't expect them to configure complex BGP policy and so on. So the next slide, please. So to be honest, I love end-to-end, right? So in ideal world, it would be really nice if host just magically choosing the correct IP address or addresses, right? And all network does is just forwarding packets. However, the main problem is going to be, again, especially in enterprise, I probably want to send all traffic through this particular link because it's cheaper. And I want to use another link as only as a backup. Or that might be some other security or some other policies to enforce. For example, this link should be only used to access some corporate infrastructure, and this link could be used to access the internet. And on top of this, indeed, we're going to see quite stupid hosts for a long time everywhere. So what's happening now? On the next few slides, I'll show some solutions I've seen, and most of them are quite ugly, but I don't think we actually have anything better. So next slide, please. So the nice options, right? You just become a LIR. You get your own PI space, PA space, or get API, right? And then everything magically works. However, indeed, the main problem, you cannot do it for every corporate network case because it means you need to run BGP, and I've seen a lot of cases when ISP would not like to do BGP to their customers, or this small office network is connected through DSL line or 3G modem or something like that. So you cannot do that. And indeed, we actually started inflating routing table because then you have to advertise some routable prefix for every location. And if I have a lot of offices, I probably do not want to do this. And I personally have a problem with assigning like /48 and V6 for office when I have 5 people sitting, right? But I couldn't assign less because otherwise it might be filtered because it will be such a small prefix. And indeed, a lot of corporate networks would not like to deal with operational and financial overhead of becoming an LIR. Okay, so it's not a solution. I mean, it's a solution in some cases, but it's not for everyone. And next slide, please. Okay, again, we have a stupid host which you can use whatever V6 address it has, and we have a network which goes around the packet properly. So the simple, again, one simple solution might be, and I've seen it working, when customer routers are advertising more specifics from both ISPs to both ISPs. And those ISPs kind of agreed to run BGP and accept those prefixes. If those prefixes are actually properly registered in ArrayDB and ISPs of the past building their filters properly, actually BCP38 problem could be solved. However, there is no guarantee, right? Because even if enterprise can convince both ISPs to accept their prefixes, there is no guarantee that no BCP38 filtering happening on upper level. And again, we're inflating routing table again with more specifics. If more specifics are filtered, there is no redundancy. Yeah, they are covered in aggregate, but if, for example, purple link on this picture fails, we'll see packet loss because traffic for prefix B couldn't reach the customer network, right? So it's a kind of solution which probably works in many cases, but again, its operational overhead would not work in case of small offices and so on. And next slide, please. Okay, in some cases, if you don't want to run BGP, what people sometimes do, what I've seen, is they just ask both ISPs to accept traffic. The problem here, we do not have proper redundancy, and in this case, routing information and packet flow are actually not in sync. So I don't think there is any way to properly register some information like registering it in IIR database, right? So in this case, there is no more specifics advertised, so most likely uplinks with both ISP might filter traffic, and there is no current way, as I said, to automate filter updates. So I don't think it's going to work in practice. I've seen it again, some people doing this, and sometimes it works, but again, there is no guarantee those packets will reach the internet, which is kind of sad, but the only benefit of this solution is actually it's quite simple from customer perspective, but and we are not inflating routing table, but again, there is no proper redundancy in case of one of the links fails, and ISP needs to cooperate, and it's not going to happen again. Okay, next slide, please. Okay, so it looks like there is no other option but to the correct uplink based on source IP. So network has to do this, right? We might, at some point, also influence a decision made on a host. However, we cannot say we can only offload all decisions to host. Looks like network and host need to kind of cooperate. So next slide, please. Let me explain why it's going to happen. So currently, actually, kind of source destination routing exists, right? People are doing multi-homing in V6 currently using policy-based routing. I'm just putting a policy on my router saying, okay, those source addresses are going to uplink A and another source address is going to uplink B. It's kind of quite ugly solution, but it's the best one we have. But indeed, it's error-prone and it's hard to automate and all these disadvantages of policy-based routing. Right? So we definitely need something better, especially for small networks when we could not expect engineers, administrators to apply complex configuration. It would be nice if it works using some dynamic information like zero-touch provisioning. But we still need to be able to apply policies, right? Because sometimes in load balancing between two ISPs, or two or more actually ISPs is required, and sometimes quite the opposite. Only one link needs to be used, and another link needs to be a backup. Or in some cases, you need to use one link to access internet, and another link to use as a backup for internet, and third link to be used only to access some particular services like corporate network. And indeed, we need to provide a fault tolerance. And I do not think we can do it without actually influencing source IP selection on hosts. Next slide, please. Because actually, my problem is I can use policy-based routing, right? I can put policy on egress routers and edge routers and send traffic to the correct egress interface. However, what's happening if one uplink fails? How can I signal to a host that I do not have any interface to route packets with source addresses from ISPB address space. This is currently biggest problem I found, and there is no actual way to solve it properly. I think in Buenos Aires, someone mentioned, like, can we send ICMP message back saying don't use this address? The problem is we probably can find a way to tell host do not use this address, but we need to signal it back when the link is back up. Because let's say ISPB is my primary and I want hosts normally using prefix B address space, and then prefix B link to ISPB goes down. So we need to make sure that hosts stop using prefix B address space, but start using it again as soon as the link is back up. So currently I've seen some, again, very dirty, ugly solutions of sending array with prefix information options with preferred lifetime 0. So basically, as long as I detect some event like link going down or routing prefix or route disappearing from routing table, I can use a script and send array from host default gateway telling please do not use this prefix for any outgoing connections. And as long as the link is back up, I can send array with PIO with normal preferred lifetime, so host can start using this address again. Ugly solutions, there is no like standard solutions. You need to use people using some scripting to do this. And the next question is what happens if it's the last available prefix for a host? What happens if both links on this picture went down? Should host stop using all address space, but it means it leaves host with link local address only. It might be internal infrastructure still available, right? For example, it might be like some local network with local servers which still might be reachable. So it's a kind of tricky situation which needs to be addressed. And so basically, I think we need to find out I would love to see some solutions which allows network to communicate such type of event back to host and still make the local network reachable, even if there is no actual internet connection. Or probably it might be actually a bad thing because, for example, in this case, people, if, for example, only V6 connectivity went down, host might still have V6 address and try to reach internet over V6 while it's only reachable over V4. So again, high eyeballs will help here, but we need to signal it back to host. And
so,
I think that,
Jen,
yeah.
let me jump in for a second. I think someone has a question. Oh,
yeah, sure.
Wait a second. I got a chat window message, but now, so let me just pause for a moment and ask if anyone has a question.
Can you hear me?
Yeah.
Yeah. Okay. So the preferred lifetime for a router advertisement is the preferred lifetime, I could be wrong, for the router acting as a default router, right?
No, it's a prefix information option. The router advertises the prefix which can be used for stateless outer configuration, and it includes two timers, right? One is preferred lifetime for how long this prefix can be used. The address derived from this prefix can be used for outgoing communication, and then valid lifetime for how long we basically use this address to accept a local incoming connection. There is another timer to tell how long we're going to use router, default router, yes, but now I'm talking about prefix information option in array.
So couldn't you announce the prefix with a preferred lifetime that's not 0, but announcing yourself as not a default router?
I can't remember what happened if you receive, I think you can, yeah, because you basically tell it, okay, I'm not your default router, so my, well, I can't remember what the timer called. The router lifetime is 0, but the prefix information option for particular prefix says preferred lifetime is not 0. I think it's quite valid situation.
And doesn't that solve the problem at hand? I doubt it, but I'm wondering why it doesn't.
But okay, the problem is that as long as host has another default router, right, it still might send traffic using this source address. the problem I'm trying to solve here, the
okay,
host.
that makes perfect sense.
Yeah. And actually, I think it's my last slide, so we can just go straight to questions. Any questions? No?
So I have one comment. This is AC. It seems that in the case where there are no source subnets available, the case you talked about, that would be a problem. You'd have the same outcome no matter what solution you pick. I mean, so it really wouldn't be a requirement. When you were talking about how if you lost all your source prefixes, if you were using RA to invalidate provider-assigned subnets that weren't reachable or something like that, I mean, you'd still have the same outcome of not being able to, applications not being able to communicate externally.
Yeah,
right?
Yeah, you are right, actually, yeah.
Yeah, okay.
So in this failure case, if you had a ULA, that would sort of solve most of the problems with accessing local resources, right? I think
Kind of, yes.
I think the problem with ULA is that it's too small for a big enterprise. Is that the only problem?
Not necessary, actually, because I think you can have /48 per site in this case, yeah, and it will not be. So as long as you don't have hosts which are using the old default address selection algorithm, ULA will never be used to communicate into global destinations, which is kind of nice, yes. To use. Actually, I think I know some enterprises which are doing exactly this. They have ULAs, they're using ULAs together with PA address space. So internal communications normally happens over ULA, using ULA addresses, and the host accessing the internet using global provider aggregatable address space, yeah. It's actually ULA might help, yeah, to keep your internal infrastructure, corporate infrastructure available in this case, yes.
So then you can do the RA PIO with preferred lifetime equals 0 without breaking things.
Yes, yes. It's actually, yes. Okay, operational problem currently is that I do not know any like big router vendor doing this, and people currently have to do it with some scripts monitoring network and doing this, yeah. But there is no way to automatically do it on routers now, at least on the routers I played with. So I cannot like say, okay, when this event happens, please do this, yeah. Because as I said, we basically, currently people can solve, so I can choose the proper outgoing interface using PBR, but it's ugly, but there is no proper solution except this one, sending arrays to signal failure scenario.
In a large network, you have to have this automated, like somehow you have to have this protocol that asks all the routers to send these deprecating addresses. I mean, like HNCP will do this, but are people going to run HNCP on mid-sized corporate networks?
Yeah, that's what I'm talking about, right? Looks like we have a mechanism, like everything in the protocol already, right? So it looks like currently what we're talking about is a kind of just a feature for router vendors. Like I want a policy, and this policy should describe when some network event happens, I want RA to be sent with such parameters. So it's not actually protocol. There's no issues with protocols. Yeah, it's just a feature, kind of feature request. But it's a problem now.
So I'm gonna jump in here so we can stay on schedule. Thanks a lot, and I think it'll be very good to lean on your experience with deploying these from the enterprise side to get some perspective as we move forward as well. So thanks. So Let's move on to Eric Osborne now.
Can you hear me this time?
Yes.
Oh, good. Goody, goody. Okay, so I will try to make this brief, but I have some stuff in here that may be contentious or confusing or ignorant on my part, so it may not be brief. So this is a network operator perspective on PA multi-homing. Next slide, please. So like it says in BA, I saw Fred's one slide and I said, well, like everybody here, I now know more about the problem and the solution than everybody else, so I'm going to stand up at the mic. And so I did. And that led me to being asked to do the same thing here. So I've dug a little bit more into the history of the questions and the answers and how we got to where we got, but I'm by no means an expert in this side of things. And in particular, this is not a particularly V6 specific thing. I'm just talking about PA multi-homing in general and some of the things we've seen with it. And these may be dead-horse questions, but I'm still going to point them out. Next slide, please. So this is a clip of Fred's slide from Buenos Aires, the whole idea of picking the right exit. We understand the problem, but this is what I started with. Very little, well, no V6 specifics here either. Next slide, please. So to me, it seems like there's 4 or 5 general approaches to dealing with the PA multi-homing issue. One is don't do that, right? That's not what PA space is for. And doing this turns it into PI space, I think. But you know, let's look at the other 4, since it seems we're assuming it's a foregone conclusion here. There are, of the remaining 4 there, you could update BCP filters to allow PA space from those who don't own it. You could push source destination routing all the way to the origin, which is to the host that decides to put the packet on the network. You could push source destination routing to the ingress router, which is the first router that sees a packet from a host. Or you could, perhaps tunnel between egress routers, which was the thing that was on Fred's slide. I just want to talk about our take, or my take, on these 5 things, just to see where it gets us. Next slide, please. Okay, so number 1, it hurts when I do this, don't do that. It's PA space for a reason. Sending PA sources through other providers makes it PI. This is impossible to deal with. We see this all the time. SWIP is busted, IRR is busted. As far as I know, the tools that we have that do our BGP filters make no distinction between PA and PI. It's all just addresses to us. That's my experience of our tools. That's all I can speak for here. This is, of course, the favorite answer, but it is completely unworkable because the cat's already out of the bag. Next slide, please. So we could update BCP 38 filters. This is the most practical. Just start punching holes in PA allocations to effectively make them PI or constrained PI or whatever you want to call them. It's hard to get right, but it is sort of what we do today. You tell us what prefixes you're going to send us, and we believe you, is the short answer. This is a whole separate problem having to do with IRR and RPKI and who knows what's next. But it is what's, at least we do today. I can't speak to others. My guess is they're mostly like this. So this is one solution to the whole thing, and it would fix a lot of this problem. I wanted to take the next 2 slides to go into a little bit of a perspective on why I think this is harder than simply enterprise does this and provider does that. So if you could go to the next slide, please. So this is kind of simple, right? This is similar to the picture that Fred drew and like a small version of the one that Jen just had, where you've got the ingress router, which is the southernmost thing here, just north of that customer host, and it can make a decision. You've got a single egress router here, and it could make a decision. You could have a pair of egress routers, as in Fred's original slide, and they could make a decision. This is kind of straightforward. The host can do something. You could push routing back to the host and have it make an A or B space choice. The ingress router could do it, or the egress router could do it. What got me on this and what kind of got me thinking is if you go to the next slide, this is where it gets harder. So I've got a customer. I didn't give them a name, but they're customer AS, and they have, it could be one router of their own, it could be several, and of course they'll have both a router north of the host and they'll have the peering routers upstream. This is the kind of stuff that we do see every now and then, probably once a week we deal with this, where I've got red lines and green lines between them, and these denote commercial relationships. And the thing I'm trying to point out here is just because you're a peer of somebody doesn't mean you're not a customer of somebody else. We have cases where I've got customers, I've got customer A and customer B is a customer of A, And then I've got customer C who peers with A, and it all gets very messy. And there are all kinds of distinctions we have to draw on this, both on the routing side and the commercial side. So in this particular case, the customer, the end customer, that southernmost cloud, has PA space from F, and they multi-home to F, A, and B, right? So they can egress select to go to F. But if they're going to send to A and B, now A and B have to update their filters. And if B and A are going to send to C, D, and E, now they have to update their filters. And now F has to take this stuff from C, D, and E. And the different relationships, peer versus customer, can be different here. Who applies BCP 38? Does F apply it to some people and not to others? Do you apply it to customers and not peers? What if the customer link to F goes down? Jen said something about this as well, and that was a late addition to my slides. I hadn't thought through that very much. But if the customer source selects based on the only person who's going to take their sources directly is gone, what do you do? So this, to me, it says, well, what is PA space anymore? You've just kind of poked so many holes in a wall that now it's a fence, right? So that's the kind of problem we're looking at. If you go to the next slide, please. So one thing you could do is you could push source destination routing to the origin. And again, this is not v6 specific. I think this is a terrible idea. It requires hosts to have some awareness of routing, and the whole point of routers is to do that heavy lifting for the host. If the hosts have some primitive heuristic, then the first hop network device, so the ingress router in the terms I'm using here, that either has to validate or sanity check or prevent or double check the host decision, and then why bother to have the host do it? The last line's kind of a jab, but internet routing to host sounds about as good to me as ATM to the desktop did. It would work if all the hosts were smart enough, but all the hosts aren't smart enough. So this is a tricky way to solve the problem. Next slide, please. So you can push source destination routing to the ingress router. This is the first router in the enterprise network that sees the packet, and have it do something, do some left-right intelligence there. If you're a transit AS, if you are in that cloud of blobs I drew earlier, if you're the guy in the middle, well, what's an ingress router versus an egress router? Some people do this differently, but for many providers, customers come in anywhere and can go out anywhere. So there is less of an ingress-egress function, whereas if you're an enterprise, you may have wiring closet first-hop switches that are ingress routers, and your egress is decidedly bigger iron than that. So if you're a transit AS, doing it in the ingress, doing the egress is kind of about the same. If you're not, if you're an enterprise, this might have a significant impact on the network. Your ingress devices might be, like I said, wiring closet switches. Adding source destination routing to them could be an uplift, could be a device uplift. It's certainly going to be a code uplift and more stuff to manage. Fred made the point about, I think it was NTT beeflets and picking specific exits for specific services. Taking a default is easy, but how do you pick specifics to go via some exits if you're not doing this on the host? Do you need v6 NAT now to rewrite the addresses and all the things that come with that? Note that I am not proposing v6 NAT, but it would help solve this problem if we backed ourselves into that corner. Next slide, please, and this is my last slide, and then I'll let people throw rocks at me. So you could tunnel between the egress routers. This was the thing Fred pointed out and said, well, can we make it better? To me, this is the second most practical. If you're going to try to keep some sanctity of PA space and push it as far out to the edge as you can, I think the egress routers have to be the ones to make that decision. This only involves coordination between egress routers, although, of course, again, in a transit provider, egress and ingress are pretty much the same. It could be thousands of egress routers. It may involve new hardware. You could do this with OpenFlow. It is policy routing, right? But only at the exit points. I still have the same kind of question about specifics and the same kind of questions about NAT. So I guess to sum it up, if we're going to try to preserve the sanctity of PA space, we have to preserve the sanctity of PA space. If we're going to pretend that it's no longer PA, then just knock holes in filters and be done with it, or solve it with RPKI or IRR or whatever comes there, rather than trying to solve it in the control and in the forwarding plane. That's all I have, so I will stop here and open for questions or objections or whatnot.
So question,
Yes.
So the last two or maybe the last three solutions are effectively semantically the same. Did I miss a solution where all the routers in the AS do source desk routing? Or is that the ATM to the desktop slide?
No, if you go back to slide 4, Chris, please. So you're right, the last 3 are all the same. It's a question of where you do it, right? So source desk routing to the ingress router is number 4.
But that's a tunnel, right?
Yeah, you could do it as a tunnel. I don't see how else you would do it. Yeah.
Well, you could, like, there are protocols that will do source desks and they will just do source desks in a routing mesh. Like, did I miss that? Like,
oh, okay, you're talking about
for example, you know?
Yeah, no, I haven't looked into it. I know they exist. I would, for me, everything is tunneled anyway because it's a BGP-free core, so it's just all LDP to the edge. There's no, the midpoints don't know anything about it anyways. If you're doing pure hop-by-hop IP, yeah, you could push source destination routing for all possible sources and all possible desks to all hosts in the network. I won't. You do as you like, I guess.
But I guess from your perspective, 4, 5, and this other one, which call it 6, they're all the same, really.
4 and 5 are the same if all of your ingress routers are also egress routers if you're a transit provider. 4 and 5 are not the same if you're an enterprise where your ingress router might be, like I said, wiring closet switch, branch office switch, where your egress router to the AS is, could be much newer hardware and much more capable.
Yep.
Right. I'm not sure I'm answering the right question, but that's...
No, I think you did answer. I think,
trying.
yeah, 4 and 5, semantically they're the same. They have different scaling characteristics and different commercial characteristics. You might not be able to do them depending on your network.
Yes.
And I think 6, though, this other one, which is hop by hop, you're basically saying, good luck doing that in any network of any size, which I guess is fair enough. But it's semantically, again, I think those 3 are all the same.
Yeah, and you're right on the hop by hop. I didn't even consider it because there's no way in hell I'm actually going to do it. It might work for smaller enterprise or someone who doesn't already have LDP or something to effectively tunnel between the points, but it didn't even come up on my radar, so I didn't put it here. Yes.
Yeah, that's the Soho solution, right? That's what HomeNet is working on. It'll probably scale to like something, some small enterprise, right?
Oh, it'd work in my house. Yeah. No argument there. Anybody else?
Okay, well, thanks a lot.
Sure. Thank you.
Thanks. And I think we're a little ahead of schedule, which is good, I guess 5 minutes ahead. So we can move on to Shuyang to talk about the progress of source desk routing in CERNet. Let me switch over to... Are you, can you speak, Shuyang? Can we hear you?
Yeah, I'm here.
Okay, thank you. I'll let you take it away from here then. Thanks.
Okay. I'm going to present the progress for source destination routing in CERNet 2. Next slide, please. And CERNet 2 is a pure IPv6 network in China for education and research. It has 25 POPs and connected with 600 universities and 4 million users. The total bandwidth of it is about 115 gigabits, and the international egress bandwidth of it is about 32 gigabits. Next slide, please. The first motivation for CERNet 2 to deploy source destination routing is for policy routing, because in CERNet 2, some universities have higher priority while others have lower. And traffic from some place, like the foreign academic database, should have higher priority. So there are thousands of ACL rules in the CERNet 2 routers, and it's very complex for the network operator to manage them. Next slide, please. The second motivation for CERNet 2 is load balancing. For example, there are 2 egress routers in CERNet 2. One is in Beijing and the other is in Shanghai. But at this moment, most traffic will go through Beijing, so making this router very congested. And the router in Shanghai is not so congested. And this makes the total latency for most traffic is very high. Next slide, please. So this graph shows the comparison of link utilization on the router of Beijing and Shanghai. So we can see the difference. Next slide, please. And in SNET2, the previous solutions for manage the network is static routing and policy-based routing. But these two solutions need to configure routers one by one, and this causes many wrong configurations. And the SNET2 wants a dynamic solution. And there is another choice, which is MPLS. But MPLS has very high learning curve, and SNET2 at this moment doesn't have any MPLS operator. Next slide, please. So at this moment, SNET2 is trying to deploy source destination routing in its network so that routers can make routing decisions based on both source and destination addresses. And SNET2 is implementing this mechanism in Bitway routers, where Bitway is a company in China, and is cooperating with ZTE and Huawei for projects. And the implementation is based on OSPF version 3. Next slide, please. So to modify the OSPF version 3, the network has to modify several LSA. And at this moment, it modifies 3 LSA, which is inter-area, and S external. And the format is defined in a draft, which should be updated. And we should append a source prefix behind them. And the format is defined in a draft of Baker. Next slide, please. Next slide, please. And for the routing table, is very similar with the routing table of the conditional routing table, except that there should be a source prefix in each routing entry. And the routing table is array of such entries, but it can be further structured into radix try. Next slide, please. And in the next few months, SNET2 is going to test source destination routing in the following scenario. The first one is for multi-homing. In a network, if a network is connected to multiple ISP, and if a host in it gets multiple addresses from the upstream ISP, so when the host sends some traffic with an address, the network should forward the traffic to the corresponding upstream ISP according to the source address. Next slide, please. And the SNET2 is going to test it with 2 SNET2 routers and 1 China Telecom router. Next slide, please. And the second scenario is for security. For example, in this graph, there are 2 senders, S1 and S2, and 1 receiver, which is D1. And among S1 and S2, S2 is a malicious sender. So the network in D1 and the router R1 should announce the reachability, should only announce the reachability of D1 with S1, and shouldn't announce the reachability of D1 with S2, so that S2 cannot reach D1. Next slide, please. Next slide, please.
It may be taking a moment to update, so I'm
okay.
So
okay,
is it correct now?
Yeah, it's correct.
Okay.
And the SNET2 is using 2 SNET2 routers and 2 China Telecom routers to test the security case. Next slide, please. And the last scenario is for load balancing, and there are some senders and some receivers, and the network want to carry out load balancing to make the load more balanced. And we are now using 2 SNAT2 routers and 2 channel tech routers, and because this is the ongoing work, and so we don't have any performance test at this moment. Next slide, please. So that's all. Thank you.
Question. So in your multi-home and testing scenario, so what do you do in the case of link failure to one of ISPs? Yeah. Yeah. So your link L2 fails, right? What happens?
Yeah. Yes. And if the host use address A, and the network should forward the traffic to SP1 and then to the internet.
So how does your host know that it should not use ISP2 prefix?
Pardon? Can you say it again?
So in this case, let's say your link to ISP2 fails, but host does not know about that, right? So it's still trying to use address B for some communication. What would your network do in this case?
And in this case, we think it's the responsibility of the host to detect the failure and switch to another address.
If it does, so it means it would never use that address again, right?
Yeah.
How would host know that it can use the address B again when link is up?
We haven't considered this into consideration at this moment.
Okay, thank you.
Yeah, thank you.
So, Shu, you have this OSPF v3 extended LSA implementation. Are you gonna post it? Is it on Quagga or is it based on ZTE / Huawei routers?
We have already implemented it in Quagga, but the code is not so good. So we will try. We are now implementing it in the Bitway routers again.
Okay. Is anybody from there coming to Berlin? I don't want to take any more time, but I'll contact you.
So this is Chris Bowers here. I had a question about the forwarding performance of this. You mentioned that there's no testing done on the forwarding performance, but given the role of this, it's very this use case is very different from the PA multi-homing use case, where the source test routing would be in a home network or an enterprise. Presumably these are 10 or 100 gig links that this would be operating on in the either the load balancing or the policy routing use case, sort of traffic engineering applications. So I was wondering if your implementation if it's general purpose CPU based or some other specialized hardware, and if you had any sort of insight into the particulars of the route lookup mechanism.
Yeah, actually we are now using DPDK, which is a software-based solution to implement the forwarding table, and we are also wondering the performance at this moment. But our operator Huawei Huawei is also implementing the same forward table with the hardware, and we will show the performance if we get any results.
Okay, thank you. That we'd be interested in hearing that as well.
Okay, thank you.
Okay, so I think next on the agenda is John Bershowski. He was actually only able to join right on the hour. So if he's not on yet, if you could move ahead. So first let me ask, is John Bershowski on the call yet? Because we're actually a little bit ahead of schedule. Okay.
That's on the list of participants on WebEx.
Right, right. Okay, so I expect him to be joining within the next 10 or 15 minutes. So if it's not a problem, can we move ahead to Ole?
You certainly can.
Okay, thanks a lot.
Right. So this is a implementation of source-based routing that we did as a hackathon event in Buenos Aires. So it's I haven't had time to look at it afterwards. So it's this is what we learned during that weekend. There's obviously a lot of loose threads here. And next slide, please. So the platform we have is called Vector Packet Processing. It's open source data plane running on DPDK or other drivers. Relatively new open source project, although it's been worked on for a decade or so. It does about 10-14 million packets per second per core, depending on what core that is, commodity hardware. We brought this, we're trying to, well, perhaps we use it in some IETF context to see, it's nice that you write a draft, but let's see if we can have some running code and how that running code would look like and how well it would perform. So during the last IETF, we did a implementation of source-based routing, one algorithm of that, yeah. So next slide, please. There's a link to the code there. You can jump on that slide. That's prettier in other presentations. So actually, we got a few people interested during the hackathon that just showed up. We hadn't spoken to them beforehand. They were interested in the project and wanted to contribute. So if any other people are thinking about doing these kind of things at hackathons at the IETF, it is certainly worth giving that a try. Doing a bit of PR ahead of time is probably a good idea to attract some people and play with code, and it's certainly something you can learn a lot from. So we were looking at the general case that Eric Osborne didn't like. I think how can you do hop by hop source-based routing in software and do it reasonably fast and in a general way. So we had two different mechanisms. We were looking at two different algorithms, either just to fib or fib, so extend the lookup to 256 bits essentially. Or, well, we did two lookups. There's a hierarchy of a max depth of 256 bits, or do a source lookup first and then duplicate entries in a set of D tables. And what we ended up implementing was the first mechanism. Next slide, please. So the current lookup we do using VPP is a hash-based lookup where we run through the prefix length in decreasing orders. You start with the longest prefix length to look up in the hash table. If that fails, you go to the next length you have in the hash table, and so on until you get a match or you fail. So this is the existing lookup we do, which is reasonably efficient for V6 tables, even with millions of roots in them. Next, please.
So Ole, in this case, the length is actually 256 bits.
No, go back. Yeah, so this is the length here is 128 bits. So this is the existing DLOOKUP, so purely for destination.
Oh, existing. Okay.
Yes.
Yeah.
Sorry.
Thanks.
Next, please. Then the SADA lookup is we extend this lookup. Well, so first we do just the existing dest lookup. If we don't have source prefixes, so we don't want to have collateral damage for normal forwarding. Then we extended the lookup so that we first do a destination lookup, then we run through the potential candidate sources for that destination, and try to see if we can find the best matching source prefix that results in the adjacent index, just like the destination lookup does. And if you match the destination but you don't match the source, then you have to go back, you have to backtrack and try again with the next longest matching destination. Next, please. There we are. I think this is on WebEx. I could have done a smaller font, but it still fits on one slide, so it can't be too complicated, right? So as you see now, we run through the destinations again in decreasing prefix length order. Then for each match, we then do the same thing for the sources. The max lookup depth here, or max number of lookups, is obviously 128 by 128, so it's about 16K, which is a pretty bad worst case. If you go to the next slide, we just played around during the hackathon event to see how bad that would be. So this is the levels here are each backtracking event. So you pretty much have half the performance if you have 4 levels of backtracking. That's probably a very unlikely table to happen. But to be able to optimize these lookups, it would be very, very nice if someone could tell me how these tables would look like. I mean, would you have 2, 4, or 8 source prefixes, or would you have 1 million source prefixes? Because how I'm going to optimize this is going to be very different depending on that. Are you ever going to have backtracking, meaning that you would have destination routes that would be different from different sources, or would you typically just have defaults with specific sources, in the general multi-homing case? Are these never going to be a problem? Are we never going to see millions of routes here and multiple levels? But so we looked at the worst case. That was what we tried to measure on, which is why we have the backtracking levels here. But as you see, from level 0, there's a very, very little performance hit just from the lookup. I mean, it's insignificant to do the additional S lookup, but that's been done with a table with just a few entries. So it's perfectly possible to do this as the mechanism, but it's perfectly possible that you can create a table as well that will have pretty poor performance if that's what you're after. Next slide, please. Right, so that's pretty much what I said. What we're trying to look at next is probably a model which is described in the draft, which is just do a source prefix table, do a lookup on that to find an index into which destination table you have, and then you duplicate entries across the destination tables. It's a bit harder to build the tables, but that gives you a lookup which has a worst case of 128 plus 128 lookups, which is much, much better from a worst case perspective. That has other scaling properties, right? It uses more memory. At least in the current implementation, we couldn't do millions of source routes that way. We could do tens of thousands of source routes quite trivially, but it would require it's basically limited by the data structures we use to handle multiple fib tables. But yes, we have to figure out at some point here, in real life, what these tables are going to look like, because that's going to drive some of these decisions. So yeah, that's pretty much a report from a weekend of coding in Buenos Aires. Questions?
Actually, I have one to Stacy. Well, can you go back to your modified pseudocode?
I can't, but I'm sure someone else can. Yes,
there you can. Okay, yeah. I looked at this. Maybe I'm not. Maybe I'm missing something.
By the way, this is
quickly. I would expected you to first do a longest match on the. Longest hash lookup on the destination, and then once you found that, then start looking at sources. But you have them nested. I might now. Granted, you spent orders of magnitude more time on this at the hackathon than I am. But why is it nested? The source lookup in the loop.
Well, the first I do the lookup on the destination.
Right. So why doesn't that complete? And then once you find the destination, why don't you do the source? Why is it? The way I see it, it's nested in the same loop. Why do you have it nested?
Oh, so I have a 256-bit hash where I essentially vary, with a wildcard mask. And I vary the wildcard mask because first, the mask is such that I only get to destination. Then I keep, the wildcard mask for the destinations fixed, and then I, spin around looking for matching sources.
Okay, why wouldn't you find? I guess it's the high level algorithm then that I'm confused on. Why wouldn't you first? Based on the discussions I've heard at previous IETFs, why wouldn't you find the longest destination first and then look at sources rather than?
That is what I do. If you look in the top there, I do.
Why don't you why don't you first look up the source and then done, and then why don't you, once you've got that source, why do you have it nested?
So can I try?
Yeah, go ahead, Eric.
So the issue is if you have, if you have longer matches that apply to some sources and not others, right? If you do longest best match, you will say, oh, here's a good route in today's world, but then the source editor says, sorry, I can't use that one.
All right, so you might backtrack.
That's the backtracking thing, right? And that's why they end up nested.
Okay, I see. Yes, I see.
And as Ola said, right, if that's part of your table, you need to be able to do this.
So you have to,
if it's not there,
you have to look at every one that matches. You have to see what sources.
Yeah.
Okay.
Yeah. And the clear benefit of this one is, the algorithm fits on a slide. It's very easy to generate the forwarding tables. There's no magic there, right? You just put it straight into the table, while the other algorithm is, well, still very, very simple lookup, but much harder to, or little harder to generate the forwarding tables.
So this is Chris here again. I would say there, the complexity, this algorithm is actually difficult to understand. This concept of backtracking I think it will be difficult for enterprise users to understand and just look at some routes and figure out what should be happening. And I think as Jen pointed out, that simplicity of the solution should be a priority. So we, even though this does make sense from the point of view of, okay, providing the right answer in all cases, we should, I think, consider just the overall simplicity of a solution that people can actually understand. So, and if that could have some side effects of, helping performance as well and just making implementation simpler, that might be good. So that's just kind of my opinion on this backtracking being confusing and potentially hindering the solution or the adoption of the solution.
So of course you don't need backtracking in the other solution. The end result is the same, right? Just that you have to duplicate routes across tables in a relatively clever way.
Yeah. So let me just point out. So the latest version of the draft, Anton Smirnov has added basically a reformulation of the algorithm. It's effective. It has the same result, but it's a different way of performing the algorithm that basically gives you does the source lookup and then multiple destination tables. So it sort of trades off operations for memory, or memory for operations. So if you haven't looked at the latest version of the draft, I know you have, Ole, but other people on the call, it's good to look at, as you pointed out, section 3.3 here.
Yeah, and that is actually a very nice description of the algorithm. Of course, if we could simplify things and say, thou shalt never put overlapping source prefixes in the table, that would certainly help.
Yeah, I mean, I think we should be open to that possibility, at least, that that it would have the benefit not just of simplifying the implementation, but the benefit of simplifying deployment, so that people could look at the table and enterprise users could look at a table and know what's going to happen. So just food for thought, I think. I did have one other comment on. Well, it's a related comment. I think we can make very good guesses about what the table will look like in terms of HomeNet and enterprise deployments for PA multi-homing, but for traffic engineering applications like we heard of for CERNet 2, if that's a use case that we want to support with this, then I think the routing table looks significantly different. So it's just it's a good reason for us to at least make a conscious decision about supporting that use case or not.
So this is Julius Krobacek. I'd like to come back to a previous point. The fact that ULA is using a complicated data structure doesn't necessarily imply that it has to be reflected in the user interface. You can show the kind of table that people are used to, while within the implementation using whatever data structure you want, as long as you can reconstruct the routing table from it, which is certainly the case with ULA's data structure.
Yeah, that's a good point. Good point. It would be even simpler for the end user to not even have to consider the backtracking. But if we need the backtracking for use cases, then that's reasonable as well.
Well, they clearly, they don't see the backtracking in tables as such, right? They just appear as, you can easily generate a table that has backtracking, right? It's purely to have two routes, both which matches the destination and with different sources. That will result in backtracking, where one destination is more specific than the other. That will result in backtracking, and the backtracking is purely an implementation detail in this particular algorithm, right? If you pick another one, it doesn't have the source table first, then it doesn't have backtracking. It's not visible to the customer apart from, or the user, sorry. We're not selling anything here, we are open source. But it will have a performance impact, right? But whatever way, most implementations today just for deep lookups will have performance impacts if you create the table in all good ways. I don't know what we can do about that, but it's certainly not visible to users here, either case, right?
So yeah, one more sort of food for thought. It might actually be useful to use the multi-fib version as the algorithm specification. If we think that is easier for people to understand, we just say that's the specification, and you can implement it however you want.
Well, let's hear the next presentation as well, because I think the Linux fib is a fib of fibs, which has, similar, is implemented in a similar fashion that we've done here with the hash. At least I think. I haven't looked at the code. But yes, specification and implementation certainly doesn't have to be the same.
Okay, well, thanks a lot for the presentation, and I think this helps to really inform a lot of decisions being made, and we look forward to hearing any updates you have on other, if you implement the other approach as well, that would be great.
I was thinking of trying out that new RFC on implementation experience template they had put there, but I can't promise that I will get around to it before Berlin.
Okay, well, thank you. So I think John Bershowski is now with us. Is that correct, John? Okay, great. So yeah, we skipped ahead one because we were a little bit ahead of schedule, so thank you.
Yep.
So I'm going to switch over to your presentation and take it away.
Thanks. All right, so that's a healthy list of participants here, so I think I know the vast majority of people. But I'll walk through here based on the chair's request is some insight into some of the things that we've looked at and are faced with from a multi-homing and provider-assigned addressing point of view for V6. Next slide, please. Essentially, the need is real. We are having to support stuff like this today. You'll see here in the next few slides. I kind of went back and forth a little bit to figure out how in-depth and how kind of complicated I wanted this matrix. But again, I kind of boiled it down to what I thought were the most fundamental items, and then I'd assume that we would be able to kind of dive in and have some deeper discussions. Just so everybody's clear, this is very much revolving around DOCSIS-based, broadband, powered services, mostly in the commercial space. But you'll see that there's a use case here that is very much residential in nature, and everything that we'll talk about here is around kind of dynamic provisioning, a la DHCP6 for PD and addresses. Next slide. Added scope, things like larger scale fiber customers who typically are not kind of being dynamically allocated prefixes. Would love to hear feedback from the crowd here if people think I'm missing something, but based on my experience with my customer base, this does not appear to be immediately a hot topic. Not to say that it won't at some point in the future, but for now the focus, the couple of use cases that you'll see here focus more on the kind of dynamic broadband-based, smaller commercial residential-based customers. Next slide. So 2 use cases. We have 2 or more egresses, each with a unique active prefix, and then we have 2 more egresses, each with an active standby prefix, but only one is active. We'll dive into the first one next. Next slide. So in this case in particular, we have a situation where we have 2 services. We have a broadband service and a video service, which are both, for this conversation, are powered by the same operator. However, that is not strictly, needs to be the case. Broadband service has its own prefix, and the video service has its own. One of the challenges that we were confronted with this, with this particular use case is we need to make sure that hosts that were video hosts, which are video only hosts, were not inadvertently addressed or attempting address from the broadband prefix and or not trying to use the broadband prefix as its egress for a video service, and the vice versa, would apply. So we had a situation where one home with 2 egresses, they would be essentially joined together in the home over a MoCA link, for example. So anybody who's familiar with MoCA, you know, would kind of have some experience in this space, but basically you have two gateways and their LANs would effectively be joined together using a Mocha link. You know, and what we've seen in this over the past, say, you know, 3 years or so is that, you know, pretty unpredictable. And frankly, you'll see, you know, later in the slides that, you know, this is some of the stuff that we had, you know, been discussing as part of the home network. So I'll look to kind of the chairs to kind of provide a little bit of, you know, adult supervision for me to help understand how or if any of this conversation, you know, pertains to kind of the home net stuff. So long story short, you know, we have, you know, service-specific devices that we would, you know, that we need to make sure use their respective egresses, and they each have their own corresponding egress. Over time, that may converge. Before I proceed to the next slide, any questions or comments? Can you hear me?
Yes, yes.
Okay, perfect. Next slide, please.
And yes, this is quite relevant for the you know, HomeNet case and other cases. Just, you know, demonstrating that this is a live problem out in the field that you're having to deal with. So this is good.
Yep. Next slide. Okay, so we have a single service. Let's just call this you know, DOCSIS-based broadband. Again, you know, two egresses. It may or may not be in the same physical box, right? So to be very explicit here, you might have two routers, one from two different service providers, or you might have a single router that happens to have a secondary interface off a secondary interface like a USB LTE type of interface, right? Effectively representing two egresses from the customer's premises, right? You know, ideally, you know, my customers, particularly of the static variety, don't really take kindly to kind of flash renumbering type of activities, especially when it pertains to, you know, how do you keep DNS updated. I mean, maybe, you know, if we kind of, you know, rub our head and pat our belly, you know, the host renumbering works seamlessly, you know, 100% of the time. But there are a number of kind of operational administrative issues that kind of ripple down from that. You know, one that comes to mind is, you know, DNS, for example. So the idea here is that we have customers that, you know, later this year, and you know, maybe there are a number of you on the phone here now that have, you know, that I've been able to kind of extend static V6 as part of some of our kind of pre-launch trials. But we have customers, you know, very specifically in that space that are looking to make sure that when they, you know, if they want to have some sort of redundancy and they have multiple egresses, that, you know, they have some sort of the technology to kind of have continuity there. You know, the case that you have here, again, provider assigned, very dynamic in nature. You know, in Comcast point of view, we still kind of dynamically assigned address blocks using DHCP, but we do have mechanisms in our back office to make it so that, you know, those are, you know, stable or static across, you know, various kind of access network maintenance. This one is probably, you know, pretty familiar to most everybody on the phone, but this is one of the ones that is, you know, popping up more and more. Next slide. So again, recap some of the highlights here. You know, this may be a single provider, like, you know, both egresses are Comcast gateways, or one egress is Comcast and one egress is not. You might have different media types, same physical device, separate devices. One of the things that we've talked about, you know, repeatedly over the years, you know, internally as well as, you know, within the IETF is, you know, in order for many of the things that we need to kind of work, there has to be at least some minimum amount of functionality that exists between the egress routers, right? So if you have an egress router that, you know, can do something like, you know, HNCP or DNCP from a home net point of view, but you have another one that cannot, you actually have a least common denominator situation, which does complicate matters. So, you know, looking back to the conversations in home net over the years and really trying to make it so that we had something, you know, basic that, you know, the industry could adopt was pretty important. You know, having minimum functionality across a wider range of implementations was more important than having kind of, full-fledged across the handful. Again, goal here, minimize customer impact. We make sure the services work as designed over IP using the right, source and destination. And interestingly enough, there's a number of things that we've done over the years to really kind of, handle the situation from a V4 point of view. Nat really kind of helped, I kind of begrudgingly say helped, but, it certainly seemed to, ease some of these challenges in certain situations. And I think, many of the folks on the phone would agree that, Nat 6.6 is certainly not something that we're not considering. We do not want to see that happen. So, the need here is real, again, to kind of point back to the very first bullet point of this presentation. Next slide, I think the last one. So what we've done, is this in fact the last slide?
Yes, I think so.
Perfect. So what we've done in a dual service case with, in a case where we have video and broadband kind of having their LANs bridged, we have implemented some kind of device-specific functionality that basically allows us to operate, a video LAN within the larger LAN, right? So we do things like, potentially disabling auto configuration and some other acrobatics and chainsaw juggling to make it so that the video devices can use the egress that are that we intend them to use. Meanwhile, we allow for co-am devices, things like laptops, PCs, tablets, etc., to kind of continue to use V6 the way that the way that God intended them to be used. Some of the things that we are looking to do moving forward is we are kind of exploring the possibility of utilizing some of the work that's done in HomeNet. A lot of the very basic stuff, and I heard Julian out there earlier, even pre-Babel type activities, things like HNZP and DHCP really did provide some of the base functionality that we needed to really manage this use case in a dual egress situation where, where we can kind of make it so that both egresses had the same level of capabilities. The single service use case, the one where we have like a commercial broadband service where you might have two routers or two different egresses in the same router. That one is still very much unfolding as we speak. And while we do not get confronted with this frequently, the sense that we're getting from our trials and our pre-launch activity is that this one will become a hotter topic as the weeks, months, and years unfold. So with that, I'll pause there, ask the chairs if I've missed anything that you wanted me to talk about. If not, then we can turn it over to questions or comments.
No, you haven't missed any topics. I have a question, but I'll wait to see if anyone else wants to jump in first. Okay, well,
administrative side, so I've got two names without family names. Lorenza, Timothy will be Kaliti. Robert, could you please state your name?
Yeah, this is Robert Rashuk.
Thanks, Robert.
Okay, thank you.
So my question was about the use cases you've pointed out here are typically it's the same network overall that they're connecting to. So the dual service use case is the video network and the internet network. It's the same service provider upstream. So it's not necessarily BCP38, but you still need, say, the video device to choose the right exit because you don't want to inefficiently route traffic, through the internet network and back to your video network.
Correct.
Okay. So,
but please note, it is not. I mean, it is strictly not. It is not strictly a case where the same northbound broadband network is going to be providing the connectivity in every case, right? I mean, I think from our point of view, well, my Comcast hat off and my IETF hat on, that's really something that we should make sure that we're caring for long term, where the upstream networks are not the same provider.
Yeah, but I mean, it's yeah, I'm not minimizing it. I'm just saying it's a use case where just solving BCP38 doesn't really fix it per se, because it's inefficient routing, and so you still need a solution to get the traffic out the right egress in the first place.
Yep. That is correct.
Okay, thanks. And does anyone else, I'll pause for a minute and let anyone else jump in. So I'll go once more. A lot of discussion seems to assume that there will be hosts that have two v6 addresses, a single host with two v6 addresses on it for each of the, for each of the prefixes, the source prefixes. But in the single service use case, it sounds like you don't have that. Is that correct, or that you see, do the hosts just have one source address, and you want to get them out both ways or not?
Well, I mean, I can tell you from firsthand experience with my customers, like many of them really struggle with the idea that a host can have more than one address for v6 from the same prefix, right? I'm not knocking my customers, but v6 is not familiar to a lot of people, right? When you have a large broadband network, you end up kind of providing service to a lot of people. Some who understand the internet and networking better, and others who do not. So the idea, I mean, truth be told, I even work with people who still struggle with the idea that a host can have more than one address, right? So the idea of those hosts now having more than one address, more than one prefix, I can just see that being a kind of a comprehension issue, right? So for starters, the idea would be to kind of make it so that you can have a single prefix active in the premises, and then grow it over time in a seamless manner. But even in your example, or in the point that you're making, having that work right, if it were to work properly, I mean, as far as packet movement was concerned, you still have some degree of confusion around, okay, which address do I use in DNS again? Because this, you got to remember, a lot of these services, a lot of these customers, a lot of these these folks using the service are not just accessing the internet; they are making service available to the internet from their premises, right? So it's the other direction, and there's a lot of other kind of internet machinery that goes into making that work.
Okay, thanks. That's good. That's good input. Yeah.
Yeah. So I have a question for you. So so this is, I appreciate your invitation to be here. Where do we go from here? Like, when you and I were or when we were all kind of going back and forth on email about kind of this topic, some of these things we've shared as part of HomeNet. Can you help me understand where we take this next?
Yes. So the motivation for this is we originally took on the work for source test routing based on HomeNet's request. V6 Ops also subsequently made a request to the routing area in general and the routing area working group to address multi-homing and with focus on source test routing. And so we are pursuing this. We have the draft we referred to earlier with the sort of the mechanics of source test routing and a particular algorithm is a working group document in the routing area working group. Fred Baker has revived a use cases draft that we're using as a mechanism to sort of define what use cases we really should be addressing here. And that's, you know, currently an individual contribution, but I think we'll use that as a vehicle to figure out, okay, what problem are we trying to solve here? And so we're moving forward to find a solution, but since we started out sort of with, okay, this is HomeNet, but then you know, the enterprise use case was sort of added later, we're taking a bit of a step back and sort of gathering input from operators and other people who have expertise on this topic to you know, get more of a critical mass and then move forward with coming up with a solution. Does that make sense?
It does.
Okay.
It
thanks.
was very interesting to me that we, in HomeNet, we did this source test routing thing, and then the L3 comes in and says, you're on crack, that'll never work. That was kind of eye-opening. Of course it won't work, right? So it was very interesting to me. And so, like you said, there's a different way of saying, like, the enterprise use case arrived later. And yeah, so running, you know, I don't think running BabelD in a large enterprise will scale, not because the routing protocol won't scale, but just in terms of coordination. It's all going to be running in PLS anyway. So I wonder if there's somewhere where we should, if there needs to be some document where we need to hold together the threads of the various use cases and say, well, this is what needs to be done in terms of in order to make multi-homing work, and then, you know, we can have a tunneling solution and a PLS solution, and then we can have, yeah, whatever, ISIS if you want, or Babel. But I wonder if we need some common document that says what the goals are of multi-homing using source test.
Yeah, that would actually be useful. I think we've you know, been having discussions around them, but they're sort of fragmented. We've been, I think, trying to evolve Fred's use cases document into that document. But if there's another approach that you want to take, that would be fine as well. I mean, that would be good input. So were you volunteering?
Oh, never.
Okay. Okay. Okay.
Because the document referred to as the use cases, right?
Correct. Correct.
Yeah.
Okay. So thank you, John. And I think we're just about on schedule to move on to the final presentation of the day from Mathieu Boutier on source-specific routing implementation in Linux. So let me pull up your presentation.
Okay, thank you.
Okay, thanks a lot.
So I'm Mathieu Boutier, and I will present you my implementation of source-specific routing in Linux, which is a joint work with Julius Hrabocek. Next, please. So first, just to fix the context, recall that source-specific routing consists to route packets based on both their destination and source address. And so we have source-specific routing table which maps pairs of destination and source prefixes to next hop. Next. So as we see, it is possible for a packet to be filtered by 2 entries, while none of these entries is more specific than the other. We think that case that the table is ambiguous, and we believe that there is consensus to say that we want to solve ambiguity by selecting the entry with the most specific destination prefix. Next. And finally, we agree that for most of the use cases, we can make some assumptions as considering that the source-specific routes necessarily have default destinations, or that the source-specific prefix are disjoint or default. However, we are interested here by the general case, so where an entry can be not default both on destination and source. So this let us more flexibility for the future, and is probably not worth it. Thanks. Next part. Okay, so to implement source-specific routing, we need to install source-specific route entries, so computed by some routing protocol, into the FIB. Thus, an implementation strongly depends on the available forwarding plane, and remark that generally these changes are incremental. Next. So there is two suitable API on Linux to do source-specific routing, IPv6 subtrees and traffic engineering. So we will see that we want to use IPv6 subtrees when available, but that in some cases it is not available, and so we must use traffic engineering rules. And our implementation use either. Next. So IPv6 subtrees is exactly what we want. It is really a source-specific routing table, and it chooses entries by destination first, which is what we want. So installing a source-specific entry is as simple as installing a classical one. We just have to additionally add the source prefix, and it's in the same netlink message, so in the same system code. So, however, it's only available for IPv6 in recent Linux kernels and in kernels which are compiled with the right options. Next. So if you can't afford to use IPv6 subtrees, you can use traffic engineering. So basically, packets pass before routing through a list of rules, and so for our concern, these rules match source address of the packet and associate a destination routing, well, a classical routing table, and then the packet is routed regarding this table like classical routing. So there is two operations to install a source-specific route. First, we must manage the list of rules, so to install the priority and the source table. And we must also install classical routes in the routing table. So the interesting point here is that you see that we first look at the source address of the packet, so it's the wrong behavior. But it works on every Linux distribution we met, so that's a good point. And next, there is a hope to do something correct. Indeed, because when if you look at the entry we had in the destination table, well, in the routing table at the bottom, we can achieve by using this more specific entry exactly the same behavior that we had in the native source-specific table. So now, in fact, the FIB is not ambiguous. Next. So in order to force the kernel to correctly route packet, we wrote a disambiguation algorithm. It maintains additional entries to keep the FIB unambiguous, such that the resulting routing table is behavioral agnostic. So the algorithm itself is protocol agnostic. It's just an intermediate layer between the RIB and the FIB. So the algorithm is also incremental and stateless. Next. Okay, so to finish a little example, so consider we have a RIB without ambiguity. So in that case, the FIB is also exactly the same without any additional rules. Next. And now let's say that the protocol receives an update for a conflicting source-specific route. So in that case, we first insert an additional entry, so the blue one, which is the last, and then the conflicting routes. So the interesting point is that you see that during the whole process, the fib is kept unambiguous, since we first added the most specific entry. Now remark that with traffic engineering, we use multiple tables, so next. But because the fib is not ambiguous, it's now just a matter of representation. So the routing is correct. You can also see on this slide some real example of a disambiguated fib. Okay, next. So to conclude, there is two ways of implementing source-specific routing in Linux, and we did both. Either using native source-specific fibs, which is better if you can, or you can also use, otherwise, traffic engineering rules, and with some work to disambiguate the forwarding plane. So we propose for that an incremental and stateless algorithm. And finally, perhaps the interesting point, our code is freely available. It's a MIT licensed code, and thanks for your attention.
Thanks a lot. Thanks a lot. Are there any questions? I did want to actually state the obvious. I think. Well, state what I think is the obvious, but make sure it's correct. This is all about implementing routing functionality that is using a Linux box as a router, and you're not looking at, even though this is Linux can be hosts, this is not really about any host functionality, because we've touched on that a bit with various routing advertisements or router advertisements and PIO and stuff like that. Just to make that perfectly clear, this is all about route a Linux server as a router.
So Julius wants to take the answer. So.
I'll take this question if that's okay. Julius Krobacek speaking.
Sure.
So this is about routers in general, and this is about implementing source destination routing in the most general framework possible, with making as few assumptions as we possibly could on the forwarding plane. Now, this is implemented under Linux because Linux is convenient, because we know Linux, because Linux is widely available. But we believe that this work should apply to a wide range of different forwarding planes. Is that your question?
Yeah. And I guess you're also saying that it could be less complex if you don't need the disambiguation algorithm, but that only applies to newer Linux kernels. So in order to sort of operate in the real world on FreeBSD or whatever Linux someone has.
In particular, we are very much interested in getting feedback from people who are familiar with hardware routers, so that we can know, we are very interested in knowing what actually exists out there and what are the available forwarding planes that are widely deployed and cheaply available.
Sorry, Mathieu. So just to add a remark about FreeBSD, so it should be possible to use it for FreeBSD, but it seems that you need to compile FreeBSD with the number of with the number of multiple tables that you want to use. So it's less convenient than on Linux.
Okay. But on the other hand, if you were putting out a server-based router, you would just go ahead and you had control over the OS. you would just go ahead and use IPv6 subtrees.
Yes.
So you would avoid the complexity of the disambiguation, but that's not always the case. Okay.
Thanks.
So with regard to your question to available forwarding planes, both Mellanox and Broadcom have recently published shim layers, so you could have access to their APIs without actually signing NDAs for SDK access and such. If you could take a look and see whether you could use it, or potentially we could try to work with, again, with Broadcom, Mellanox, and probably others, to get APIs to be able to program their hardware natively for source-specific routing. If you could take a look at least what's available now, would be great.
It may be interesting, and if you have some contact, it may be good. Perhaps send me an email.
Okay.
Okay, well, if there are no more questions for Mathieu or Julius, thanks a lot. I wanted to ask if there are any questions, not specifically about this presentation, but just in general about the topic, or any sort of open the floor before we shut down the call.
So this is Julius speaking again. I missed the opportunity to ask Eric earlier a question about his presentation. Is Eric still around? Eric Klein.
Eric Osborne, I believe.
So yeah, Eric Osborne had to drop off.
Okay.
So you can.
Thank you.
Okay, thanks. Okay, well, if there are no questions,
See, I had a question. So, what do folks think about like the architectural view here? I think perhaps here we're just rightly so. Perhaps we're focused on like moving the bits around and moving the packets around. But what if people think about where we would take the whole view, like, you know, how to communicate, you know, how to route the packets, but also how to communicate this information to hosts, for example, via DHP options like, you know, like the prefix preference option. How do we communicate to hosts that their prefixes are deprecated? Like, where should this work go? Because the routing is just just one part of it, right?
Well, I think this is Fred Baker. I think there's a couple of obvious places for it to go. 6min has recently sent to the ISG a document that talks about prefixes advertised in RAs in routing options and default options and this, that, and the other, and how the host might select its first hop router given a source address that it's chosen. So I think 6man from the host perspective probably already has an answer, and if it's not an adequate one, then let's talk about that. Once the packet gets out into the network, it seems like the obvious places are going to be the routing protocol working groups.
Yeah, I think, yeah, okay, so what you're saying is put it in, you know, split it into pieces inside each working group, right? Maybe that works. Well, one thing that 6man hasn't said yet is what happens when, you know, do we deprecate a prefix when we know its egress link is down? We haven't had that discussion. I mean, HomeNet might have talked about that.
And I actually don't necessarily agree with Fred that you know, maybe ultimately the specific work is done in 6man, but I do think if we truly want to develop a solution that works, we need some overall cohesiveness to it, as opposed to individual pieces that clearly states what assumptions we're making and what piece of, you know, other protocols we're relying on. Because I think people on this call are making different assumptions at this point based on their knowledge.
Well, so
yeah.
One thing I've been trying to avoid doing is materially changing the existing architecture. We could certainly take some variation on a routing protocol, and Babel might be an example, to the host. And historically, we've avoided doing that.
So let me respond to that one, and then
Sure.
I'm fine with that. At this point, you know, I think everyone's idea of the existing architecture is different. We haven't really. There may be a few people who have a common understanding of how this would be done, but it would be good to actually just say, okay, I want to use DHCP or router advertisements for this, and these are the extensions, and have that in one common place, as opposed to, you know, sort of 5 documents that we implicitly know, oh, we're talking about that document. So I even think there's work to be done on just saying what the existing architecture is.
Yes, I would like to respond briefly. The first thing I'd say is it would be really useful to have a document that articulates the full pieces of the problem, whether that's with pointers or not. I feel like one of the question marks that I keep coming back to are things like, but, you know, the failure cases, what happens with the host interactions, et cetera, as well as the use cases. And I think that it may be more useful to have that in a single document that gets last called, you know, in multiple working groups and is available to point to and say, yes, this is the full problem that we're talking about, than it is to sort of put it into piecemeal. I do think we are suffering from different assumptions, and I mean, this meeting was very useful to hear how the enterprise use cases are rather different, obviously, from the service provider, and getting more of these details written down would be really, really helpful.
Okay, thanks. So there's a chat message from Aaliyah, but obviously you've gotten your microphone working. So yeah, I think we've covered that. Okay. So I think as I mentioned before, we will continue this discussion both on the mailing list as well as in Berlin. We're going to sort of keep the momentum going here. And not try to drag this out too long, but gather in sort of all the relevant input and then move forward in some manner. So I'll probably be reaching out to you, or if you would like to, if there's a particular aspect of this that you'd like to talk about in Berlin, reach out to Jeff and I regarding a time slot, and also, you know, bring up any of these issues on the mailing list, and let's get an active discussion going. So I'll open the floor one more time for people to talk, and if Jeff has any comments as well.
No comments, just to thank everybody for joining us, and it's important work.
Yes, thanks a lot for participating. So we'll sign off now and talk to you later.
Talk to you later. Thanks.